In the next part of this unit, we're going to work on trying to simplify some square roots. If you take a look at a number like 50 and think, oh, what's the square root of 50? It's not one of those that's a nice whole number. But what we're going to do is we're going to take a number like 50 and we're going to break it up into 25 times 2. When we do that, part of that we can simplify. The square root of 25 is 5. And we end up with an answer of 5 times the square root of 2. So when we run into a number whose square root we can't simplify as it is, we're going to try to break it up into parts in such a way that we can simplify part of it. So let's look, for example, at the square root of 18. When you have a square root that you're trying to simplify, you're going to break it up into 2 square roots, and you're going to try to find a number that goes into 18 that's something that you can take a square root of. You're looking for perfect squares, things like 4, 9, 16, 25, 36. You're looking for those numbers that you can take square roots. And we can take the square root of 9. 18 is 9 times 2. So here our answer would be 3 square root of 2. If we look at our next one, the cube root of 40, the difference here is we need to split it up into cube roots. So I see a lot of students on this problem who split it up into 4 and 10. If that was a square root problem, that would be absolutely the way to do it. But with cube root problems, that doesn't help. We can't simplify the cube root of 4 or the cube root of 10. So with cube roots, you're trying to find a number whose cube root you can simplify. And honestly, almost all the time with the cube root problems that you're going to run into, the ones you're going to be looking for are either 8 or 27. In this case, the cube root of 40 is the same thing as 8 times 5. And the cube root of 8 is 2. So here we end up with 2 cube root of 5. Let's take a look at a few more of these problems. Our next one, we have the square root of 20. So with the square root, we're trying to break it up into 2 square roots. And we try to think, what's a number that I can take the square root of that goes into 20? And it's one of the earlier ones, 4. This 4 goes into 20. And so we split up 20 into 4 times 5. The square root of 4 is 2. So our answer is 2 square root of 5. Or if we look at our next one, the cube root of 54. With cube roots, remember you split it up into 2 cube roots. And as I said a minute ago, with cube roots, you're almost always looking for 8 or 27. 8 doesn't go evenly into 54, but 27 goes into 54 twice. So here we have the cube root of 27 times the cube root of 2, and the cube root of 27 is 3. And notice it stays a cube root that whole problem. 3 times the cube root of 2. So let's try a few more. The next one, the cube root of 27. Square root of 27. With square roots, we're breaking it up into square roots, and we have to think, what number can I take the square root of that goes into 27? And in this case, it's 9. 9 goes into 27 3 times. So we make it the square root of 9 times the square root of 3, and the square root of 9 is 3. So 3 square root of 3 is the answer. Or the last one, the square root of 54, unlike the cube root problem up above, splitting it up into 27 times 2 wouldn't help in this case because we can't take the square root of 27 or the square root of 2. We need cube roots. Remember with square roots. With square roots, you're looking for numbers you can take the square root of. And in this case, a number that we can take the square root of that goes into 54 evenly is 9. 54 is 9 times 6. So we split that one up into the square root of 9 times the square root of 6, and we end up with 3 square root of 6 for the answer. So pay careful attention to what type of root it is that you're trying to work with. All right, so let's take a look at the next one, the square root of 34. If we tried to split this one up into the square root of 2 times the square root of 17, that doesn't help us. We can't simplify the square root of 2 or the square root of 17. So you simplify them when you can, but this is a case where you really can't simplify it. There's no way to split up 34 so that you could simplify just part of it. Now, you're not going to run into very often in your college algebra classes fourth root problems that you would need to simplify. But if you do need to simplify fourth roots, you're usually looking for either 16 or 81. In this case, for the fourth root of 32, 16 goes into 32 twice, and the fourth root of 16 is 2. So we would end up with 2 times the fourth root of 2. And now to keep going, let's look at roots of variable expressions. We said earlier that to do square roots, you divide it by 2. To do cube roots, you divide the exponent by 3, and so on. Well, here we run into a case, the square root of x to the fifth, where 2 doesn't go into 5 evenly. There's a remainder when 2 goes into 5. And the way you work it out is this. You're going to have an exponential power, and we're going to have something left under the square root. 2 goes into 5 twice with a remainder of 1. So since it goes into 5 twice, we have x squared. But since there's a remainder of 1, we still have x to the first left under that square root. To take a look at the next one, here we're dealing with fourth roots. The fourth root of x to the 11th. So let's think of that same process. 4 doesn't go into 11 evenly. So we know we're going to have part outside a root and part under the root. To look at the part outside the root, 4 goes into 11 twice with 3 left over. So since it goes in there twice, whoops, let me switch colors here. It's not responding. We would have, it stopped responding. I need to twist the top of my sides. There we go. Since 4 goes into 11 twice, we would have x squared. There's a remainder of 3 when 4 goes into 11, so we still have, that should be a fourth root of x cubed, like so. All right. So let's take a look now at putting all of this together and taking roots of expressions that are combining numbers and variables. So for example, the square root of 49x cubed. When we look at the square root of 49, that's just 7. Let's switch back to something that writes. When we look at the square root of x cubed, we think, well, 2 doesn't go into 3 evenly, so we're going to have part outside the root, part under it. 2 goes into 3 once with the remainder of 1. So it's x to the first square root of x to the first. Usually people would write those expressions without the 1 exponent. So it'd be written as 7x square root of x. Let's take a look at our next one, the square root of 81y to the 11th. The square root of 81 is 9. And then for the square root of y to the 11th, remember what we're thinking of is 2. How many times does 2 go into 11? We're going to have part outside the root, part under it. 2 goes into 11 5 times with a remainder of 1. So we have y to the 5th and the square root of y to the 1st. That's it. So when we look at a problem like our next one, the cube root of 54x to the 6th, y to the 8th, we can really look at this as 3 separate problems. There's the number part, the x part, and the y part. Looking at the number part of this problem for the cube root of 54, we've actually done that problem a little while ago. Remember, with cube roots, to simplify number expressions, you would split it up into 2 cube roots. And you want to think, what's a number that I can take the cube root of that goes into 54? And as we said, you're usually looking for 8 or 27. In this case, it's 27. We split 54 up into the cube root of 27 times the cube root of 2, and the cube root of 27 is 3. So we have 3 cube root of 2. Next, we look at the x part of the problem. For the cube root of x to the 6th, remember, we think, how many times does 3 go into 6? It goes in there twice. So we have x squared. The next part with y, 3 doesn't go into 8 evenly, so this is one of those where we know there's going to be part outside the root and part still under the cube root. 3 goes into 8 twice with the remainder of 2. So that's going to be y squared cube root of y squared. And usually what you'll do at this point, you'll take everything that's not under the root and put that at the front, 3x squared y squared. Everything that is under a root, you'll put together under one root sign. So here we'd have the cube root of 2y squared. Let's take a look at another one. Here we've got the cube root of 24a to the 4th b to the 9th. So for 24, we would split that up into 2 cube roots. And remember, with cube roots, you're usually looking to split it up with 8 or 27. In the case of 24, 8 goes into 24 3 times. And the cube root of 8 is 2, so we have 2 cube root of 3. Next, we look at the a to the 4th. 3 goes into 4 once with a remainder of 1, so we have a to the 1st times the cube root of a to the 1st. Next, we look at b to the 9th. 3 goes into 9 exactly 3 times with nothing left over, so we have b to the 3rd, like that. And then to finish the problem, we're going to take all the parts that are not under a root and put those together at the front. So we've got 2a and b to the 3rd. And then we take the parts that are under a cube root and we put those together under one cube root sign, the cube root of 3a.